Ever opened your fuse box and seen those little switches with a T or test button? You know the ones. They just kind of sit there day in and day out doing, well, what do they do? Turns out they're one of the most important safety devices in your entire home. So today we're going to pull back the curtain on these unsung heroes, residual current devices, or as you'll get to know them, RCDs.
So here's the game plan for this explainer. First, we'll talk about why we even need this silent guardian. Then, we'll dive into how it performs its perfect balancing act. After that, you'll meet the whole RCD family and its super talented cousin, the RCBO. And we'll wrap up with how you can make absolutely sure your guardian is awake and on duty.
All right, let's get right into it with the most important question. We're surrounded by electricity every single day, and we barely give it a second thought. But, the potential for things to go wrong is always there.
I mean, think about it for a second. A frayed cord on your kettle, maybe a dodgy power tool in the garden. In those moments, what is the one thing that stands between a little spark and a life-threatening electric shock? What is that invisible line of defense that keeps us all safe?
Well, the answer is this little guy right here, the residual current device. Now, it's not designed to protect your TV from a power surge. That's a different job for a different device. No, the RCD has one incredibly critical mission: to protect you from a fatal electric shock. It does this by detecting the very specific kind of fault that happens when electricity decides to take a detour, like through a person. So how on earth does this little box perform such a vital task? Well, it all comes down to a really beautiful and actually pretty simple principle of physics. Let's take a closer look at how it all works. The whole operation is built on something called Kirchhoff's current law. Now, don't worry, it sounds complicated, but it's not. Just imagine your home's wiring is a big, closed loop of pipe. The amount of water flowing out has to be exactly the same as the amount of water flowing back in, right? Well, electricity works the same way. The current going out on the live wire must perfectly match the current coming back on the neutral wire. What goes out must come back. And this is exactly how the RCD uses that law. Inside every single RCD, there's a tiny coil that is constantly watching the current on the live and neutral wires. Normally, everything's fine, the currents are perfectly balanced, they cancel each other out. But the second a fault happens, let's say you touch a faulty appliance, a tiny bit of that current leaks out of the system and goes through you to the ground. The RCD immediately senses this tiny imbalance, this residual current, and bam, a relay trips and cuts the power, instantly. Now, as you can imagine, our homes have filled up with all sorts of complex electronics, right? And that means the job of protecting us has gotten a little more complicated too. It turns out not all electrical faults are created equal, which is why we now have a whole family of RCDs. Each one is a specialist for a different kind of job. This chart is actually pretty cool because it tells the story of how our homes have evolved. The basic Type AC RCD, that's fine for simple stuff like lighting circuits. But modern gear like washing machines or EV chargers, they can create totally different kinds of electrical faults, like pulsating DC currents, that a simple Type AC just might not see. That's why we have Type A. And for even newer tech like heat pumps or solar panel inverters, you need even smarter guardians, like Type F or Type B, which can detect a whole range of weird and wonderful fault currents.
But, protecting you from a shock is only half the battle. There's another danger lurking in our wiring: overloads and short circuits. And for that, there's a device that does it all. It's time to meet the RCBO.
Okay, so this is the key difference right here. An RCD is a specialist. Its job is to protect you from shock. A regular circuit breaker, or MCB, is also a specialist. Its job is to protect the wiring from overloads, like when you plug in too many things at once. Well, an RCBO, that's a residual current breaker with overcurrent protection, is a two-in-one hero. It does both jobs. It protects you from shock, and it protects the wiring from overloads and short circuits, all in one neat little package.
All this technology is absolutely incredible, but let's be honest, it's totally useless if it doesn't work when you need it most. So how do we know this silent guardian is actually awake and ready to jump into action? The answer is all about incredible sensitivity and mind-blowing speed.
Just look at this number, 30 milliamps. That is the tiny, tiny amount of leakage current it takes to trip a standard RCD. To put that in perspective, it's an incredibly small amount of electricity, way less than what it would take to cause serious harm. It's just sensitive enough to know that something's wrong and that a human life might be at risk.
And it detects that leak with just astonishing speed. An RCD will trip and cut the power in as little as 25 to 40 milliseconds. That is literally faster than you can blink.
It's faster than a single beat of your heart. It's so fast that it stops a dangerous current in its tracks before it can cause severe injury. It's a race against time, and the RCD wins every single time.
So, how can you be 100% sure that this high-speed mechanism is ready to go? Well, the designers thought of that, and they built in a little fire drill. Every single RCD and RCBO has a test button, and its job is written right into the safety standards.
Seriously, pressing that button is so important. What it does is create a tiny, perfectly safe electrical imbalance inside the device, basically faking a real-life fault. When the switch clicks off and the power cuts, that's your confirmation that all the sensitive internal parts are working exactly as they should. It's the only way to know for sure that your RCD is ready to protect you and your family. And you should be doing it regularly, maybe every few months.
Which really brings us to our final and maybe most important point. This incredible, life-saving piece of tech is sitting in your home right now, just waiting. It's a guardian, working tirelessly in the background for you. But it needs you to check on it every once in a while. So I'll just leave you with this one question to think about. When was the last time you tested yours?